Hello all. So let's continue with another problem, which is also in hard category, but it's similar to the last problem that we have solved. Count unique characters in all the substrings. Okay, so here they ask total appeal of a string, and what is mean by appeal? Appeal is number of distinct characters found in a string. So what we have to do, we have to find total appeal of all the substrings. So both the problems are somewhat similar, or you can say almost similar. Just there's a minute difference that we will see. Okay, so we will see that the logic remains the same. So as I said, in count unique characters, what we did, as I said, we will go other way around, right? We went other way around, like think opposite. This is what we discussed already, that we think opposite. And what we did, for rather than finding all the substrings first, we focused on each character, and we saw that whether that character belongs to how many substrings. Okay, and uniquely in that substring, whether that character is uniquely or not. So same thing we will follow, that for each character here, instead for this uniqueness that was there in our previous problem, in this problem it's appeal. So we will see that how much that character corresponds to each substring or contribute to each substring in the form of appeal. Okay, so the minute difference between the two problems, let's see that. The minute difference is that here you can see for ABA, the unique characters are just one. Okay, so we are not, because A is repeating, only one is the unique character, that is B. Okay, but in this case, what will happen is, let's say we have ABB, right? Then we will say our appeal is 2 rather than 1. In that case, it was 1, just unique character A, but here it's not the case. Similarly, the same thing for this, where appeal is B. So that's the minute difference that we have to consider and take care of it. So again, we will use the same method, and as I have like couple of approaches. Okay, so all these are mentioned here step by step. Let me just take this. Oops, why? This always happens. Okay. So what we have to do, let's take. So I'll write entire code thoroughly. So firstly, let's go back to the same code, which is this one, right? So let's remove rest of the code. Let's copy paste it somewhere so that if we need later on, that's better. Okay, and if you will see, this is same code as this. Okay, it's the same, just a minute difference that I'll explain with on the whiteboard so that it's easier to grasp. Okay, so let me just open the notepad and paste it temporarily. Okay, so I am pasting it in my notepad. I did it, and let's continue. So as I said, in this problem, what we did, let's visit that. So in this problem, what we did, if we were having the string ABA, then what we were doing, we were putting the parentheses, right, or braces too, and we were counting how many possible parentheses combinations are there both on the left and right. So for this character A, on the left side we can just put 1, but on the right side, right, we can put 2. We can't include this one. Okay, this A is repeated, that's why we can't include. But now this is not the case. We will include this as well. Okay, because we know that this A is also a part of this substring entire ABA, right? So that's the difference. So we will do the same thing, that for the left it remains the same. Okay, so let's see the logic. This is the same code as we had for the previous one. Okay, except what I did, let me just uncomment first. So I have already written the comments to save the time, because lectures are a bit lengthy then to follow. So as I said, it's same as the unique character problem. And what we have to do, we have to just modify the right side, as I already said, and time and space both are off and off. But what we have to do is, as I explained, that in this case, in order to find the right variable, right side, what we were doing, we were not going beyond this point in unique characters problem, but now we can go, right? So just we don't have to consider the edge case, even if it's repeating. We don't have to consider the edge case, which was this one, that when it's a last occurrence, then we have to use this. We will use this always. So we will always go to that point. So what this means, this might be confusing. So for example, let's calculate for ABA on a fresh page. So let's take ABA and let's take this character A. So on the left side, we will just have 0. 1, right? One parenthesis that we can place. On the right side, we have 1, 2, and 3 places that where we can place, right? Because all these substrings, right? A, AB, and ABA. All these 3 will have this A as an appeal, which will be accounted, right? Here, even though appeal is 1, here appeal is 2, and here appeal is 2, right? But still, appeal is there, right? Because we have 2 unique characters, A and B here, right? Whereas in case of the other problem, 8 to 8, count unique characters, instead of 2, here it was 1, right? So on the left side we can put, but on the right side we can go all the way around, right? So let's try to compare. It's really good to compare and learn Leetcode problems. So for the right side, what we were doing, we were checking whether if it's the last occurrence or not. And if it wasn't the last occurrence, then we were not going beyond that point. You can see, let me have everything in one line. So this condition was executed, that we were checking its next occurrence and the current occurrence, right? But we don't have to do this right now in this problem. Why? Because as I explained, that we have to include this A, unlike the other problem where we discarded this A, right? So on the right side as well, we have to go 3 steps. So how we will find this 1 and how we will find this 3? So 1 is the same thing, that how we will find this 1 is we are using the same thing, that if it's the first occurrence, then we will use this formula. That so right now it's the first occurrence, right? We are calculating for ABA. And mind it, just here are all the lower cases, and there in that problem there were upper cases, but doesn't matter, okay? But just be careful, okay? So what we would have to do, the J is the dictionary, right? Let's debug this so that we know what we are doing. Let's have the debug mode, and let's move this somewhere. Okay, so we know that. Okay, and let's take ABA. That will be better. Okay, test case. Let's stop it. Let's take A, B, and A. That's one. Oops, one of the test case, and run it. Okay, so it's ABA, and now let's debug. So what is happening here is that firstly, we know that A is occurring at these 2 places and B is occurring, we consider the same example, okay? So going forward, firstly, now we are at this position, okay? For this character, we are at the J is first, 0th position, okay? That is the first index or 0th index. It's better to say 0th index. Now how we'll calculate left? We know that our J is 0. So we will calculate left as simply whatever it's this value plus 1, right? Because we know that on the left side we can just put 1, okay? So we get left as 1. And for the right, as I said, this time we have to take into consideration the last A as well. We don't have to ignore that. So we can place 3, right? And how we can place 3? We know that length is 3. So length of S will be 3. This will be 3 minus, what's the value? 0, right? At this, right now our J is 0, right? So whatever is the value here, it's 0. So it's 3 minus 0 is 0. So we are getting right as 3. You can see right as 3. If we multiply, okay, we'll get 3, and we'll add that to the sum variable and update it. Okay, now let's move to next position, which is this one. Now we are going to last day. Okay, now what we will see here, that now since J is 1, it will use this condition, and we need this condition. Why? Because for this A, where are the points where we can put our braces? Let's see that for the last day now. Again, ABA. And now let's focus on the last day, which is this one. So on the right side, we can just put 1. We know that. But let's calculate the left side first. So we can put here, we can put here. Okay. And we now don't have to go here. Why? Because we know that while calculating for this A, we already considered the string ABA. And it's up that what is the appeal of this? Now why to consider ABA again with this as the focus? Because right now our focus is on this. Why to consider that again, right? So this time while going to the left side, we have to consider whether it is occurred before or not, whether it's the last occurrence has already occurred or not, because this is, sorry, not last occurrence, but what was the previous occurrence? Let's call it that way. Last occurrence might be confusing. So whether it has already occurred previous or not, we have to consider that. And that's why we will just go to until 2 places. And how we will find that 2? You can see we will just take current is 2, right? Value is 2 because j is 1 right now. So whatever is at the first index, it's 2. And whatever it's the previous index, which was 0. So we will get left as 2. So let's see if we're getting left as 2 or not. Yes, we are. And on the right side, as I said, we will use length of string is 3. We know that. And we know that what's right now j is 2. So 3 minus 2 is 1. And we know that we have just one place. So right is 1. And if we multiply, we'll get 2. We will add it into our summation. Okay. So that's the minute difference, that while calculating the right variable, we are just modifying it. Let's finish this. Okay. So now we are at character B. A is done. So for character B, again, we know that just one occurrence of B. So we know that j is again 0. So how we will calculate that? We will just put this value will be 1 because it's at the first index, this 1 and plus 1. So it's 2. And we know that there are 2 places for B. Let's focus on B now. Okay. So for ABA, if we focus on B, then we know that on the left, how many places we have? We have 2 places, correct? So that's why we are getting 2 in the left. So let's run it and let's see if we are getting 2. Yes, 2. And on the right side, we know that B occurs at which index? First index in the original string, right? It's at the first index. And what's the length? It's 3. So 3 minus 1 is 2. And we know that we have 2 places on the right side. You can see this one and this one, correct? So total combinations will be 4 combinations. So right will be 2. So total will be 2 into 2, which is 4. So 4 will be added to the sum now, and we are getting 9. Okay, and I think we are done. We return the sum and we know that we are getting 9 and we need 9. Okay, so that's the minute difference. It's the same code. I just removed the condition, which is this one. Okay, you always need length of s minus this thing. Okay, and in order to not utilize length of s, you can just put length of s as n on the top and use just n here. Okay, but doesn't matter. So that's the thing that we have to do. But if you notice that one thing is that, do we need all the occurrences of A? Like here in this case of ABA, right? Where we, sorry, it was here. Yeah. So here in this case of ABA, what we did, and if you compare ABA and ABA, what we get here and here, let's compare first. So you can see we are getting 8. Okay, but here we will get 9. Just one extra because we are considering that one extra. Now coming back to the point that, do we need to track all the occurrences? Right? Here just there were 2 occurrences. So we need both of them. But do we need to track all? For example, let's say we have 3 A's here somewhere down the line of the string. We have 1 more A or 2 more A. Do we need to track all of them? And the answer is no, because we always need the very last occurrence. If we are at this, then we just need this occurrence. And for example, let's say we have 1 more A somewhere ahead. Let's take that example. Example for ABA, BCA, right? For this, to calculate this, we just need this value, because we know that we can't go beyond this, okay, on the left, because this is already calculated when we were calculating this. If we go beyond this, because on the right side we are going until this A, so we already calculated all the substrings that contribute to this character, so we don't go beyond this point, right? So that's the reason that we always need the current occurrence and the last occurrence. We don't need, now this is not needed at all, because we already calculated. For this calculation we needed this, but for this last A we don't need the very first A, we just need the very previous occurrence of it. So we can avoid iterating to all the occurrence, okay? So we can save some, even though it will be again O of n in worst case, but still we can save some, okay? Still time complexity will remain O of n, but we can save some comparisons or some iterations at least. And how we will save that? Let's see that. So as I said, we just need to track the last occurrence, okay? Whether what was the last occurrence. So let's write that. Let's keep this as it is so that we can visit this in future. And let's keep approach 2. And let's stop the debug and minimize this. Approach 2 only track current and previous occurrence. Again, as I said, time and space is O of n, because we are visiting all the nodes, okay? So does nothing change, but it's good to learn all the approaches. So let's do that. Let's copy, at least we need this, and we don't need now the default dictionary of list, because we don't have to store all of them, okay? We will just store the last occurrence or the current occurrence. So rather than using this, what we will do is I'll just use default all the index, all the values, I can say, for all the keys in the character or in the hash map will be -1 by default. I'll print it so that it's easy. And since we have all the lowercase values, it's written in the constraints that S consists of all the lowercase characters. So here what we are doing is simply we are creating a dictionary from A to Z, all lowercase, okay? ASCII underscore lowercase is the method, okay? It's not the method, it's the attribute, you can say. So what this will give is all the A to Z lowercase characters. And what we are doing, we are just simply iterating over this hash map, okay? And even though for this since we are iterating on the hash map, we are going through even O of 26. So here O of 26 is going on. It's not like it's not going on, okay? So and again we will use our sum, which will be our answer. And what we have to do, we have to just iterate through the string. Since we need index, I am using enumerate because we haven't stored any index as of now, okay? So how we'll calculate left? Left will be simply I minus hash map of character. What does this mean? This mean, for example, this ABA, firstly I will be 0 for this A, so 0 minus -1, so it will be +1. And we know that for this A on the left side we just have to put, or we just have place for one parenthesis, right? And we need 1. So this is how we calculate. That's why this -1 is useful. Instead here what we did, here we use 1 plus, okay? We did this, okay? But here what we are doing is we are doing like this. We are just taking whatever is the last occurrence value, but we know that there is no last occurrence, okay? For this A, when we will visit this A, what will be left value? It will be, this is at second index, so it will be 2 minus, what is the last occurrence? So we have to store now last occurrence, Okay, so last occurrence at 0. So this value will be 0. So it's like we will always update this hash map. If there is some occurrence, then we will update corresponding to that character its index, that it has already occurred in last time at this character. And then we move to next character, we will just update it to its previous character. So every time we update it. Okay, so first it will be -1, and we know the meaning of this -1 because it will give us 1. It's doing this job 1 plus that we needed over here, right? So this can be done directly like this rather than doing this, that if it's 0 then only if it's somewhere else, because we know that by default our previous occurrence is -1 and we know that the current is at 0. It's just doing 0 -1 rather than writing this. So instead of writing this entire thing, we can just write like this, write this, doesn't matter. Okay, so that's what we are doing. And on the right side, it's the same. We are using the same thing. Okay, nothing is changing here. So we are just using length of s, and we are using at which index. So this is the index. We know that where it's occurring. Okay, so we know that it is I in this case. So we are using the same, and rest remains the same. Okay, just we have to update the dictionary or the hash map, I mean. So let's just copy that rather than writing it, that this remains the same. Just only thing is, at every iteration I need to update. Okay, so for example, when a already occurred, okay, then rather than its -1 value, now it will be 0th value. Okay, so the next time when a occurs, we will take, rather than -1, we will take 0. We just need to track its previous occurrence, very previous occurrence. Okay, and that's it, and we have to return the sum, and this will work too. Same logic, nothing changes. Okay, let's comment out this first. It ran both of them, and of course we know that it ran from top to bottom. So it ran bottom at the end, but yeah, and you can see if we submit, it will work. Yeah, you can see it has saved a lot of time, but worst case it's often, this is also often. But let's try to run the above one and see that how much we are saving. Okay, I hope Leetcode will give us, because this is not giving every time the correct thing, but let's try. Okay, we are really slow, right? Previously we were at least bit around 60, 65, right? So that's how it works. Let's again uncomment and comment. Oops, should have used Control Z, but that's fine. So this is what we can do. But what I found I found one more solution, which was even way faster. Like not that much. I just need to comment this line. Not that faster. I mean, in terms of comparisons, but at least, so you can see every time it's giving different. But this is the bug of Leetcode, or not the bug, but it's like they are also using some internal servers, right? Or some servers means some system like Linux or Windows or whatever. So every time it takes it, because it might be executing someone else's code. So every time it takes a bit different time. So please ignore that. But what matters, it's big O notation, that it should be often, and that's it. Okay. But what I found one more solution. Okay, and this was like, I will never be able to come up with such a solution, and I'll just simply copy paste and let's uncomment so that it's readable. So this is a bit mind blowing for me, that I mean, now it seems that it's nothing, but it's the same thing. Again, we are creating A to Z all with -1 as a dictionary. Again, this is total and this is current. They're using two different variables, and total will be our answer. So what they're doing is simply iterating to the string. But rather than all this left and right, this can be done very simply like this, that whatever is the index, whatever is the last seen, now the hash map is last seen. Okay, you can call it hash map again just to avoid confusion. Okay, and let's put it as a hash map. And put it here as well. as a hash map. What they're doing is they're just simply taking firstly the index, that is I, which we had here, the I, and its last occurrence. So firstly it will be -1, and they're just taking the difference and appending into the current, and every time they're appending the total. And this is the what we also did. Okay, so the same thing, just index is I, or I is index in this case, and at the end we are returning the total. So no need of all this. So this was not that intuitive, but now it seems intuitive that we are just checking on the left side, nothing, but that's it. We are just doing this thing, and we are just appending whatever is the left value, what we are getting, we are just appending. So it's like they're just focusing on the left side, like how much are on the left side, and that's it. But this is like bit not possible to get it alone, and that's why I found this from one of the solutions, which was the fastest. Like here you can see this one. So I found this from here, and I just took it just to show you that how it works. So that's it about this video. I hope these two questions really important to know the difference. There's a minute difference, really important, and might be asked. Like usually hard problems are not asked, but these are like not that hard, you can say, counting unique number of characters or counting the substring. So at least now we know that how to calculate the substrings. Okay, all the substrings, and we can utilize the same logic in some other problem where we need to find some substrings. We can utilize this logic, right? So that's it about this video. Thank you and stay tuned.